Hi there. Today we're going to have a look at scatter diagrams, also called scatter graphs. We are going to look at the types of correlation that we can expect. We're going to look at how to apply a line of best fit, and then we'll look at a couple of examples of how to actually draw the scatter diagram. The scatter diagram, it shows us the correlation between two sets of data. The connection between two variables. It shows us a relationship between two sets of data. There's three main types of correlation. The first one would be a positive correlation. The definition of this is that when one set of values increases, the other set of values increase. So what you would expect to see is the scatter points would produce a trend that is pointing upwards. A positive correlation. An example of this would be as the temperature outside increases, the number of ice creams sold would also increase, bringing about a positive correlation. If we think about the amount of time you spend studying, so if your revision increases, the amount of hours you spend revising, your grades at school are also going to increase. So again, that would produce a positive correlation. We also have zero correlation, which is also known as no correlation. This tells us that there is no connection, no relationship, no correlation at all between the two sets of data. You would expect a scatter diagram with the scatter points not to form a trend at all. An example of this would be if we plotted shoe size against intelligence. Those two variables have no connection to each other, they have no correlation at all, so you would say that there was no correlation. We also have negative correlation. This is when one variable increases, the other variable decreases. What we would expect to see here is the scatter points producing a trend, but this time pointing downwards. So even though we're talking about a negative correlation, that does not mean there isn't a correlation. That means there is a connection, but it is a negative connection, a negative correlation. For example, as the temperature on the day increases, the amount of hot drinks you would expect to be sold would decrease. If we think about school again, the amount of days you have absent, as they increased, your school grades would decrease. So there would be a negative correlation between how many days of absence you had and how good your school grades were. Okay. When we're dealing with a positive or negative correlation, we need to also be aware that we can describe the positive correlation as strong, moderate, or positive. A strong a strong correlation is when the scatter points are very closely spread about the line of best fit. The scatter points here are very close to my line of best fit, indicating a strong positive correlation. For a moderate positive correlation, the trend is still positive, the trend is still going up, but the scatter points are just a little bit more spread out about the line of best fit. For a weak positive, we still have the trend going up, but again, the scatter points are spread even further from that line of best fit. This also is true for negative correlations. We have a strong negative where the scatter points are very close to the line of best fit, very close together. There's not much spread in the scatter points. For moderate negative, the trend is still going downhill, but the spread is a little bit further away from the line of best fit. And for a weak negative, the trend is still visible, but the scatter points are just further away once again. Okay, we need to be able to draw a line of best fit. A line of best fit is drawn so that it follows the general direction, the trend of the points on the scatter diagram. The main thing to remember is you should try and get roughly the same amount of scatter points above the line of best fit as below. So for example, we have here a positive correlation. The trend is going upwards, so we refer to it as a positive correlation. Using my ruler, I could draw on a line of best fit. Notice that I've got 4 scatter points above the line of best fit, and I've got 4 scatter points below. There is also 2 or 3 or 4 scatter points on the line, but I've tried my best to get the same amount of scatter points above the line of best fit as below, and that helps us get the line of best fit to be as accurate as possible. This time we're dealing with a negative correlation. The trend is going down. Line of best fit goes through the center of the data. We have 4 or 5 scatter points above the line, so we need 4 or 5 scatter points below the line. There's no exact science to this. It's just a case of making sure you draw your line of best fit as accurate as possible. Your line of best fit may differ slightly from somebody else's. So when we go on to deal with the line of best fit and how we can use it, we often talk about estimating, because your line of best fit may be slightly different to someone else's. They might have drawn it slightly further up the graph. Both could be correct, because we would be dealing with an estimate when we come to answer questions. Okay, so how do we actually go about plotting data points and drawing a scatter graph or scatter diagram? Here we go. Here's a question we're going to work through. The table below shows the shoe sizes and mass of 10 men. So we've got 10 men and we've got data of each person, shoe size and mass. So we're going to plot this data into the scatter graph. Notice that the axes are already labeled, and we've put one variable along the x-axis, one variable up the y-axis. The first man has a shoe size of 5 and a mass of 65. So I'm going to go along to 5, I'm going to go up to 65, and I'm going to place my first scatter point. At this point, you can probably notice you can use crosses or you can use dots for your scatter point. It's just personal preference, really. The second man has a shoe size of 12, so he has much larger feet, and he is a lot heavier, 97. So we're going to go along to 12 and up to 97 and put a scatter point. For each of the remaining 8 men, we are also going to plot the scatter point at the appropriate position. Sometimes when you're plotting it, you may end up with 2 scatter points that are in exactly the same position. That's fine. So I'm just going ahead and plotting all the data here. And finally, for my 10th man, he has a shoe size of 8 and a mass of 80. So I go along to 8, up to 80, and plot the final scatter point. So here's my scatter graph. We can see already that we are seeing a trend in the positive direction. So we're looking for, or we already know it is a positive correlation. Positive correlation. I'm going to add on a line of best fit. So using my ruler, I'm going to draw a line of best fit, remembering that I wanted to go through the center of the data, keeping the same amount of scatter points above as below. So that looks like a pretty good line of best fit. I've also called the correlation positive. As you can see, it's going in the positive direction, probably a moderate positive correlation for this question. So that's telling me that there is a connection between shoe size and the mass of a man, which we probably would have expected. The bigger your shoe size, the bigger your mass. As your shoe size increases, your mass also increases, generally speaking. Okay, so now we're actually going to use that line of best fit to answer some mathematical questions. So for example, can we use our line of best fit to find the mass of a man with shoe size 10.5? So this man is not included in the 10 men up here. This is an extra man. He has a shoe size of 10.5. So I go along to 10.5. If I was to draw a line up to my line of best fit, wherever I hit my line of best fit, I read along onto my other axes to find an estimate of the weight of that man. The shoe size of a man with a mass of 69 kilograms. So again, I'm using the line of best fit to get my answer. 69 kilograms is around about here. I would come across on my graph until I hit the line of best fit and then read down in order to estimate the shoe size of that man. So let's see if I can just add that to my drawing here. Okay, so for the first question, C1, I go up at 10.5 because the man has a mass of 10.5. I read along and my estimate, remember it's an estimate at this stage because your line of best fit might be slightly different to somebody else's, has a weight of 87 kilograms. For C2, the shoe size of a man with mass 69, I come along at 69 kilograms, I go down, and again it's an estimate, but I'm estimating that that man's shoe size would be size 6. So there's a good example of plotting data to produce a scatter diagram, but also using your line of best fit to answer some mathematical questions. The questions in this box here are very similar to questions you would expect in a maths test or a maths exam. Okay, let's try one more example. So this time we have data on how many hours were spent watching TV and how many hours were spent doing homework by a group of students. You can see there's 15 students involved, so we've got 15 sets of data. They are going to be the coordinates that I plot on my scatter diagram. We're going to plot each bit of data. So for student 1, they spent 2 hours watching TV and 15 hours doing homework. So I plot there for my first student. For the second student, 14 hours watching TV and 7 hours doing homework. I'm just going to go ahead and plot the rest of this data. Try and follow each student and where I'm plotting their values. Okay, I'm now going to add a line of best fit to my data. Notice this point here, we would call this an outlier. Because it is so far away from the trend, I'm not going to include this when I draw my line of best fit. We call it an outlier. My line of best fit shows a negative correlation. The line of best fit goes through the trend pointing downwards, a negative correlation. And again, we ignore the outlier over here and we focus on the trend of the data. This point is known as an outlier because it does not fit the pattern. So we do not include it in our line of best fit. And as I mentioned, this scatter diagram shows a negative correlation because the trend is pointing down. If I were asked a further question and I wanted you to estimate how many hours watching TV did a student who did 10 hours of homework, we could use the graph to find that. 10 hours of homework, I could draw my line across until I meet the line of best fit, which is here, and read down onto my other axes, and you can see it's round about 10.5 hours, maybe 10 hours and 20 minutes or so as an estimate for a student who did 10 hours of homework. Okay, so that is 2 good examples of how to plot a scatter diagram and also how to interpret your line of best fit and answer some mathematical questions. Okay, so now it is your turn to have a go at a few questions. There's 4 questions in total. You have the ability to pause the video for as long as you need on each question. So I'll talk you through question 1. This set of data shows the maths and science test results of 8 students. So we've got a set of data representing 8 students, and you have 4 things to do on this scatter graph. First of all, you need to plot the scatter graph. I've helped you out by showing you what your scatter graph axes should look like. Notice that they are labeled. So first of all, I'd like you to copy and complete the scatter graph by plotting all the data onto the scatter diagram. Then I would like you to comment on the correlation, positive correlation, no correlation, or negative correlation. I'd like you to add an accurate line of best fit using your ruler. And then using your line of best fit, I would like you to answer question 4. Estimate the science mark of a student who achieved 80 in maths. Okay, if you would like to pause the video now and have a go at question 1. Okay, welcome back. I'm going to display my answer so you can mark and assess your work. My answer looks like this. So you can see I've plotted my data points here. I've described the correlation as positive as the trend is sloping upwards. The trend is in a positive direction, so it's a positive correlation. I've added my line of best fit. Remember, your line of best fit might be slightly different than mine, but as long as you have more or less the same amount of scatter points above as you do below, then it would count as an accurate line of best fit. And then to answer question 4, I've used my ruler. I've went up at a maths mark of 80 until I hit my line of best fit, and then read along for a science mark somewhere in between 76 and 79. Again, remember this value here might be slightly different for your answer if your line of best fit is a little bit different to mine. So there is a little bit of leniency when it comes to this solution, but you can't be too far away from this range. Okay, question 2. Could you copy and complete the scatter graph and answer the associated questions? You may want to pause the video now. Okay, welcome back. My solution looks like this. So we've plotted the information onto the scatter graph. This time it is a negative correlation. Our trend is sloping down. The line of best fit runs through the data, trying to get the same amount of scatter points above as below. And then I've had to use my line of best fit to estimate the amount of scarves sold on a day when the temperature is 18 degrees. So I've went to 18 degrees, I've went along until I hit my line of best fit, and then read down to get an estimate of how many scarves were sold. Somewhere in between 18 and 24 would be a good answer. Remember, we have a little bit of leniency here, depending on where your line of best fit was drawn. Question 3 of 4. You may want to pause the video here and have a go at question 3. Okay, welcome back. My solution for question 3 looks like this. We're dealing with a positive correlation. You can see it's actually a strong positive correlation. The scatter points are very close to my line of best fit. I've added my accurate line of best fit, and I've used that to find the answer down on the x-axis here. Somewhere in between 155 and 165 would be appropriate, remembering that you can be a little bit out of that range depending on your line of best fit. Final question. Again, you may want to pause the video. Okay, welcome back for the last time. And my answer looks like this. So again, we're dealing with a negative correlation. The trend in the scatter points is going downhill. I've added an appropriate line of best fit with my ruler, and I've used that line of best fit to come along at an arc mark of 35 until I hit my line of best fit and read down to this value. Somewhere in between 71 and 76 would be an appropriate estimate for the maths result of that student. Okay, so if you have 4 very accurate scatter graphs drawn and you've been able to answer all the questions associated with those scatter graphs, you've shown some excellent understanding of interpreting and drawing scatter diagrams. Very well done.